is chapter 5.8, problem number 37. And it says domain and range. Graph the function, then identify its domain and range. And I'm going to point out a couple interesting things here about the calculator and domain and range and interval notation. So this is the expression that it wants us to graph, the formula that it wants us to graph. I should put in here y equals. And I have put that over here on the calculator so you can see how it's written out in calculator ease. So what I did first was I would go, after I got this entered in the calculator, I would go zoom 6, and the calculator would produce this very strange looking graph. And I really can't see it that well. I can probably answer the question from this, but I would like to see this a little bit better. So the first thing that I did was I went into Window, and I changed my X minimum to -5, and my X maximum to +5, because I could tell by looking at the graph that that was pretty much the extent of my X values that I was really concerned about. And I left the scale at 1. But my Y's I was really unclear about. It looked like they might go down pretty far. So I started out with a -25 and then a +25. And I changed the scale on that to 5 so it would be a little bit easier to follow the notches. And then I pushed graph as opposed to zoom 6. And sure enough, it made it look a little bit better. But the one part of this graph that was still bothering me a little bit, even though I could answer the question of just domain and range from this, is this section of the graph right in here. I really wanted to know what was going on in there. So what I did was I went back into my window, and I changed my X values to 0 and my maximum of 5. I left my scale at 1. And I changed my Y values, so I didn't want to see like all the way down to the bottom. But I changed my Y values to -1 and then +5. So I really wanted to zoom in on this part of the graph. And I changed my scale on the Y also to 1. Now I pushed graph again. And now I could see really clearly that I have going on in that little spot right there is actually there are 2 local minimums and a local maximum right there. And without zooming in, I really don't think I could have seen that. So I'm going to go back to zoom 6 so you can see what the whole thing looked like originally. It's very hard to see. And that section that I isolated was that section right in here, so you could see the local minimums and the local maximums. The answer to this problem is, let's get a pen, is the domain, and I'm going to write this in interval notation, is parentheses, infinity, comma, oops, I'm sorry, -infinity to infinity, because my X values, this is my domain, my X values, because as you can kind of see over here in the graph, they will go all the way to infinity that way and all the way to infinity that way. And then my Y values, well, I would actually have to find out for my range. I'd have to do a little bit more work here. So if I want to find out my range, I'm going to go back here and change my window. I want to be able to capture. Well, I'll go back to -5 here, just so I kind of widen out my graph a little bit. -5 and then 5 there for my X's, and I'll go back to my Y's. I want my minimum to go to -25, and I want my maximum to go back up to 25. I said my maximum back up to 25. I'll change my scale again to 5 so that it doesn't get too crowded, and I'll look at my graph. So my range here, well, my lowest Y value is right here. My maximum Y value is going to be infinity, because as I can tell from the the degree of this formula. I'm going to have x squared over here. I'm going to have x squared over here. That's x to the fourth, and then two more x's. That would be x to the sixth. Is going to be my maximum degree of this equation. And so I know that my end behavior, and since there's no negative coefficient, my end behavior is going to be up, up. So I know that my y maximum is going to be infinity on both sides of this graph right here, but I don't know what my y minimum is. So I'm going to go to, looking at the graph, I'm going to go into second calc, and I want to find what my minimum is, number 3. So I first need a left bound, and I can see that my cursor is over here, and one easy way, instead of kind of running the cursor all the way around the loop, is to just enter in a number. So I'm going to enter in a number, and I'm going to say let's let x equal to -6. So I know, see, I wrote in here -6. So I know that it's going to be way out here someplace, and I don't really care what the x number is, but it's going to put my left, oh, it didn't like it, probably because it wasn't showing. Let's try that again. So I'm going to go graph. I'm going to go second calc. So I'll go again. I'll go to, I want to find a minimum, which is 3. Let's be a little bit more systematic here. Let's go to x equals -3. Let's try that. So left bound is -3. Does it like that? Yes, it likes that. And my right bound, well, again, I want to just get to the right side of my minimum, which is down here, so I'll say x is equal to 1. So my right bound is, I'll say -1. And now I don't want to guess. I'll just enter. And it's going to tell me that my minimum is y is equal to -21.28. And that is at x equals -1.6. So the way I would write that, I'm going to write my range. I always start at the lowest value, so I'm going to go -21.28, comma, and I know that it goes all the way up to infinity, so my range, it goes up to infinity, and that's my range, which are my y values for this function. So there you have it.